Alright, time for the cool stuff in the genetics. So you're just like bogged down and tired of Punnett squares. Finally, we get to some neat stuff in genetics. So we have the case of the glowing kitten. So we have, and this is real, we have a jellyfish here. Jellyfish is naturally glowing. These jellyfish actually glow in the dark. Alright, so you could, if you lived in an area where the jellyfish are, you could actually go out and see them at night. Well, this cat is also real. However, cats, you know, do not glow in the dark. This one was made to glow in the dark. Alright, so what we're going to do is we're going to figure out how we made that cat glow in the dark. Alright, so wouldn't that be cool to have like a fluorescent cat you never lose in the dark, or a dog you send out and you can see them where they go and you don't have to walk around with a flashlight? Gene splicing is pretty much the process of how we do it. Alright, so that's another goal for today, is to describe gene splicing, which is pretty much how we get cats to glow in the dark. So if you know what splice means, which means to cut, you might be able to figure that out. Alright, so why is this relevant? Making cats green is not all that important, although it's kind of cool, especially if you could do it to other animals, which you can. You can do it to mice and other animals. But this is how we make insulin for diabetics. All right, we can take insulin is just a protein, and you know genes make protein, so we can take that gene. I don't want to give it away, but we can use that gene for insulin and make insulin for patients by doing something with it, and similar to what we did with the cat. And then we can extract the protein, the insulin, and put it into people. We can also create genetically modified food. So a lot of the foods that you buy at the grocery store have been genetically modified, and we'll talk more about that later on. I don't want to give those away. All right, so what you're going to do is you're going to find out how the cat has been glow to green, and then we'll get into the genetically modified stuff in the next activity. So just to give you an overview, so the first part, again, fill this stuff out at the top, but this first part is just predictions. Just think about back to what happens in our bodies, what do our bodies create to give us our different traits, and think about what might have happened naturally and then unnaturally here to make these guys glow. And it's just a prediction, can't be wrong here. Then for this one, you're going to go, there's a PowerPoint online. You're going to go through the PowerPoint and you're going to put down, so the potato is actually called the Super Spud as the title, but it's also called the potato. And you're going to say, what's the organism? So the organism is a potato. And what we've done is all these things have gotten genes from other organisms put into them. So what organism did the gene come from that we're looking at in the potato that made it a potato and not a potato? What's the point of that gene? Why did we do it? And then there's a question and a thought bubble on the posters. So you're just going to do that and see different examples of this technology in action. And then we're going to come back to the cat. So we're going to talk about gene splicing and how this cat turns green. So you just read the top and it will give you this information for this here. You should already know what a gene is by now, but if you don't, it tells you right up at the top. And then you're going to have to get pieces of paper with the cat and the jellyfish DNA on it. You're going to cut them out and you're going to tape them together. So let's see, I don't have the picture of the DNA on here, but you'll cut them out and you'll match up the symbols. All right, so there's symbols on there, and just paste them together. You can make both of them into a circle, or however, you don't have to make the jellyfish one into a circle, but you'll definitely make the cat one into a circle. On the jellyfish, you have to find this sequence of DNA, which is the gene that is making the jellyfish glow in the dark, and you're going to highlight it and answer those questions. And then you're going to take it and cut and take the cat DNA and put it together just like you did with the jellyfish if you didn't already do it. And then you're going to cut along dotted lines you see in the DNA sequences, and you're going to cut out the GFP gene, and you're going to then put it into the cat DNA. So basically I kind of gave away what you're doing, but if you go through the directions, you're just going to do that, and then you have to make sure you answer those questions in here and then do these questions here. So summarize the process that you just completed, do this. Try to think about this extension here that I kind of mentioned at the beginning. How do we we make the insulin for diabetics? And then you can go back and answer this and see if your prediction was right, or if not, make say what really happened. All right, so that's what you're doing for the case of the glowing kitten.